Hello good people, I'm going to talk about rounding when adding or subtracting. You are welcome to pause the video and try solving these two problems yourself first. Alright, the first problem is 2428 plus 160. This will give me 2588. Alright, I'm gonna analyze these numbers in terms of significant figures. The first value has 4 significant figures. The second value has 2, and my result has 4 significant figures. So how should I round this value? The rule for rounding when adding or subtracting states that I should round to the least accurate position. What does that mean? Recall that each digit in a value has a particular position. So I'm going to rewrite my values in the table on the right. So I have 2428 and then I have 160. The first value, 2428, is accurate to the unit position. The second value, 160, is accurate to the tens position. So the second value is less accurate. This means that this value will dictate how I should round my result. The result should be rounded to the nearest 10. So if I'm rounding my result to the nearest 10, then this is my rounding position. I look one to the right, it's 5 or more, so I raise the score. And 2588 is rounded to 2590. So the value has been rounded to the nearest 10. Let's look at the second problem. So now I have 500 minus 20. That will give me 480. How should I round this value? Well, let me analyze the values first. 500 has one significant figure, 20 has one significant figure, and my result, 480, has two significant figures. I need to round to the least accurate position. So I'm going to use the table on the right again. I have 500 and I have 20. The least accurate position is the 100th position. So this means that my result should be rounded to the nearest 100. And so looking at the result, this is my rounding position. Again, I look one to the right. It's 5 or more, so I raise the score. 480 becomes 500. Admittedly, this looks a little bit odd. I had 500, I subtracted 200, and somehow I ended up with 500 again. But remember, this is a rounded value. Yes, we are introducing an error, but as long as we can trace the source of that error, that is perfectly fine. And so, at the end, I should also say that this 500 is rounded to the nearest 100. All right, I'm going to recap the rule, and for that I'm going to scroll down a little bit, and I'm going to state once again that when adding or subtracting, the result should be rounded to the least accurate position. Now, so far, I have looked at whole numbers only. How does this look when I start using decimal numbers? So here are two more problems. Again, I suggest you pause the video and try solving them yourself first. So the first problem is 173.128 plus 3.7. That will give me 176.828. Once again, I'm going to analyze the problem for significant figures. The first value has 6 significant figures. The second one has 2. And my result has 6 significant figures again. So how should I round this? Well, the rule remains the same. I should round to the least accurate position. So I'm going to use my table on the right. The first value is 173.128 and the second value is 3.7. The first value is accurate to the thousandths position. The second value is accurate to the tenths position. So the second value is the least accurate value, and therefore it will dictate how I'm going to round my result. The result should be rounded to the nearest tenth. So this means that this is now my rounding position. I look one to the right, the value is less than 5, therefore I'm just going to drop the rest of the digits. And my rounded value will be 176.8. So I could say that I have rounded to the nearest tenth, or I could say that I have rounded to 1 decimal place. In effect, it is the same thing. Let's look at the second problem. Now I have 56.427 minus 3.5. That will give me 52.927. Again, I'm going to do a quick analysis of significant figures. The first value has 5 significant figures, the second one has 2, and the result has 5 significant figures as well. I need to round to the nearest accurate position, so I'm going to use the table on the right. I have 56.427 and I have 3.5. And again, the first value is accurate to the thousandths position, while the second value is accurate to the tenths position. Therefore, my result should be rounded to the tenths position. So that means this is my rounding position. Again, I look one to the right, it's less than 5, which means I can just drop the rest of the digits. And this will give me 52.9. And again, I have rounded to 1 decimal place. Or you could say that I have rounded to the least accurate position. So rather than using this table on the right, there is a bit of a shortcut when it comes to the rounding of additions and subtractions when dealing with numbers that have decimal places. And the shortcut is essentially this. The result should have the same number of decimal places as the value with the least number of decimal places. So in both of these cases, the value with the least number of decimal places had only 1 decimal place, and therefore the results were rounded to 1 decimal place as well. So to recap, I'm going to scroll down again and restate the rule. When adding or subtracting values with decimal places, the result should be rounded to the least accurate position. This is the same as rounding to the least number of decimal places. That is all for now, and I will see you on the flip side.